All right, SNMP. When it comes to SNMP, remember, this is our simple network management protocol. We use this to communicate and to share data about all of that. Now, what I want you to note about that is there's many different versions. There's a 1, 2, 3. Now, ESX will support version 1, 2C, and version 3. The problem is version 1 and 2 are all set in clear text. Version 3 is the only one that you can utilize encryption with, but that does get a little hairy sometimes. At least version 3 has a better form of authentication than what you see with version 1 and 2C. So what we're telling you here is that if you're utilizing SNMP, go in and try, if at all possible, to set that to version 3. It is the most secure. You can go check out what's going on with regards to the SNMP itself by going to the snmpd.conf file. That's the daemon file associated with SNMP. Set that to version 3, but keep in mind, if you're not set to version 3, it's really easy to gather a lot of intel about your ESX servers just by sniffing or by asking for information regarding that. It's amazing what you can grab from SNMP. All right. One of the things that is a concern with regards to your ESX server is having that root file system fill up. When you do a default install, it only sets up a few directories, not all of them that you need, and it minimizes the size of those directories. Now, we don't always recommend going by the default. VMware tells you that, and that's why we have that here in the slide, is that we always use the partitioning that they recommend, because that's what they're telling you to do. But we don't necessarily say that's the absolute best way to do things. Sometimes that root directory needs to be a little bit bigger. There is some different recommendations out there across the globe. I'm going to tell you that you need to just go investigate those and take a look at them, because they're going to be different based upon your particular installation, based upon your particular environment. What I do say you must do, you need to create a home directory, a temp directory, and the var log directories. If you do not create those directories, it's going to fill up the root directory, and you could potentially cause a denial of service against your entire ESX server. It will die, quit, and you're said and done. So create those directories so that all of your user information, your temporary information, your log information is being stored in the right place. That's really important for us to note. Now, with the introduction of vSphere 4, we now have the ability to use USB devices. Now, although that is useful in many instances, it's also something that is scary, because now a hacker could very easily gain access to a system through a USB device. And one of the most recent hacks that I was reading about that occurred in the US government, well, actually it was just recently released, but it occurred a couple of years ago, was simply that of using a USB device. When I'm out doing consulting or I'm working with some banks, one of the common things that I do is I will put some hacks on a USB device and I'll throw them around the parking lot where they are. 9 times out of 10, I end up being able to hack into the systems because a user, an administrator quite often, has taken that USB device and plugged it into a system, and voila, I have access to it. Now, I know that it's a little more tricky when it comes to the vSphere environment, but it is still potential. What's even scarier is that somebody might put some legitimate tools that you're going to use for your vSphere environment on a USB device along with something that's not so good. So that's something to keep in mind. What we're saying is if you don't need it, disable it. Dump the USB altogether. Only enable it when you actually have to have it. Otherwise, remove it altogether. Of course, just like anything else, isolate, isolate, isolate. Isolate all of the infrastructure-related networks. The areas of concern that you need to be considering. Now remember, we're talking about many different ways that we can communicate and connect into these different systems. ESX and the virtual center. Wow, how does that all play together? Where does that pull in? What communication strings are concerned there? We need to pay attention to that. You've got the ESX and the other ESX hosts. Remember, they communicate together as well, communicate from one to another in a virtual center environment. You've got the ESX, the virtual center, and the systems running the remote management apps. You've got the vSphere client, and you've got the vSphere SDK, the software development kit. There's other management resources out there as well. What about all of your backup solutions? You know, what are they doing? How are they communicating in? There's a lot of new tools out there that communicate with all of these as well. Something as simple as vShield zones. It's a firewall management interface, but it communicates with both the virtual center and the ESX server itself. All right, now we also have the ESX and management services like DNS, NTP, your syslog, your user authentication servers, maybe using Active Directory, whatever it might be. Consider all of those communications. If at all possible, isolate what you can isolate. Don't have them all bundled together, if possible. Your virtual center also supports services like your database. That needs to be under consideration. How does that occur? Where is that communication occurring? Can we separate that from some of the other devices? You also have third-party management tools, which I made mention of, like the vShield zones. You got the hardware monitoring systems, optional add-on components, and then we could go on and on and on. Don't forget your storage devices as well, how they communicate, how they are all interconnected within these different devices. All of those communications, those paths, need to be considered. Isolate them as best as possible within your given environment. I'm not saying you go out and spend millions of dollars on new equipment. Do what you can within your existing environment. And then you get to something, you're like, this is a real risk. This is something we need to slow down. You know, maybe, you know, between your virtual center and your ESX, that should be separate. That's all management. That should not be part of your standard corporate network. At least separate those items. All right? All of the networks that are used for the different communications provide direct access to the functions of your entire virtual infrastructure. That is why we want those things isolated. The remote attack would almost always begin by gaining access to the normal network. Remember, if you're an organization that has one network and everything's part of it, I'm going to most likely hack into an end user first. And then from that end user, I'm going to use chained exploits and I'm going to propagate or move myself from one to the other. So that's something that you need to consider, because we need to have all of those things separated. vMotion traffic is not encrypted. Yes, do you remember that? vMotion traffic is not encrypted, but it doesn't need to be part of any network. It doesn't need to be part of your management network. It can be totally separated. You reduce the risk of having anybody access that stuff. It's very, very useful. Then, of course, your storage networks, they're typically not encrypted as well. iSCSI, NAS, of course, NAS is not encrypted. And Fiber Channel. Fiber Channel could be encrypted, but it's normally not. With 4.1, now we can also utilize IPsec over these different devices as well, which is something that we couldn't do as well. So consider encryption when it comes to isolating networks across your entire infrastructure. All right, mitigation techniques within VMware. Create separate VLANs for your networks. You don't have to do physical. VLANs work just fine. Remember, a VLAN in the VMware virtual infrastructure is more secure than a physical switch using VLANs. Why? Because it's a dumb switch. It doesn't have the additional functionality. It can't do as much, so therefore it is more secure. Also, configure the network access for each network through its own virtual switch. Yes, use its own virtual switch. And then, of course, you can use one or more uplink ports. The VMware virtual switch, by design, are immune to those different attacks that we usually see in a standard VLAN functionality. We can't do VLAN hopping in this environment, so it is more secure. Avoid the use of VLAN 1 for the native VLAN. You don't need to utilize that. That can cause some issues with the physical VLANs as well. So utilize some different numbers associated with your VLANs. Now, with regard to VLAN 1, the physical switches use the native VLANs for switch control and management protocol. And those native VLAN frames, they are not tagged with any VLAN ID in many types of switches. Now, where the issue is this causes a problem with regards to the ESX server and how that all fits together. the trunk ports will always treat all untagged frames as native VLAN frames. So VLAN 1 is of course the default native VLAN ID for all or many of the commercial switches. However, in many of those enterprise switches, the native VLAN might be VLAN 1 or any other number depending upon, of course, the type of switch. Now the issue here is that ESX server does not support the virtual switch port groups configured to VLAN 1. In other words, if it receives a packet that contains the tag for VLAN 1, it will simply drop all of those packets, which is not good. So ESX will handle any of the VLAN tags between 2 and 4094. So that's what you need to keep in mind. That's why we want to avoid the use of VLAN 1. All right, we have issues or things that we need to consider regarding encryption of the communications between the clients and the ESX or ESXi server. Remember, when you log in with the vSphere client to vCenter or ESX, and your communications between the vCenter and the ESX or ESXi server, and of course your remote command line interface, we're utilizing some forms of encryption. You got SSH, of course, when you're using the service console. Everything else is going to utilize the SSL encryption, and that helps protect the data that is flowing between the client and the actual server, whether it's Virtual Center or ESX, and of course from Virtual Center to ESX itself. The problem is that the default certificates that are utilized are unsigned. They are not trusted. Therefore, you always get that certificate warning. These self-signed certificates are vulnerable to those man-in-the-middle attacks. And therefore, if you're going to utilize that type of encryption, you need to know what's going on. And when you receive a warning, you need to ask yourself, is this what I expect or is this not? Remember, you install the certificate, it shouldn't pop up. If it does pop up, error flag should go on. The problem is we've trained ourselves across the board to hit ignore when those certificate errors come up. We've done a really good job of training ourselves to do that. That's a bad thing. So if you intend to use encrypted remote connections externally, consider purchasing a trusted certificate and including that or making that part of your infrastructure. Also, you might laugh at me. Label your networks clearly. It's like, well, wait a minute. We're not talking about a physical data center where we got to go in and label all of our cables and know exactly where it is, where it's coming from, what's going on. I have seen virtual networks. They've done a poor job of labeling things within the infrastructure, and it's hard to decipher what's what, who's where. You know, they got a VLAN, they don't label it properly, they don't assign it properly, and now things get screwed up. And it's an issue with us understanding where everything communicates and how this all fits together. You can limit the user access rights to only select administrators to make the change using Virtual Center. We don't want to make all of these changes within the service console unless, of course, it's absolutely necessary. So remember to set that as well. Everything that we've discussed looking at setting up the access to Virtual Center and not using the service console, or not even using some of the remote command lines for some of this stuff. But in essence, set up the virtual networks properly, label them clearly so when you walk in and you look at it, you know what's going on. It's not a confusing mess. Having a confusing mess makes mistakes and it leaves holes and gaps in your security. Now we also have a default port group. When you install ESX and ESXi initially, it'll ask if you want to create a default port group. Do not create a default port for the virtual machines. Why? Because it actually puts that on the same network interface as the service console. We do not want that. You need to keep those VMs and the port groups associated with those VMs separate from the service console. So when asked that, don't do it. The service console should always be on a separate private network. It should never be part of the standard virtual machines. Everybody loves promiscuous mode, right? You get to cause a little trouble, create a little havoc, be a little crazy in what you're doing. Now, the default setting in a VM infrastructure is to reject promiscuous mode, to not allow it. Remember, running promiscuous mode allows us to sniff or capture all of the traffic with all of the virtual machines on that particular switch. if that's how we have things set up. That's not a good idea. We want to keep that separate, just like a normal switch. We don't want to have it a hub where we can see everything. We want to have it a standard switch so that one virtual machine cannot see the other unless, of course, they're communicating with one another. So it's set to reject by default. We recommend you leaving that at that level. It can be set at either the virtual switch level or the port group level. And that's what we want to keep into mind, is to make sure that's always set to reject. Now, when it comes to protecting ourselves against MAC address spoofing, what are we going to do? Remember, it's easy for a bad guy or a user that wants to do something malicious to go in with a tool like SMAC or KMAC, and there's many others out there as well. Go into his operating system and change the actual MAC address of his system so that he is somebody else. And now all the communications from this server would actually go over here to the bad guy, the evil doer, because he's a bad guy. So we'll make all the X's on his face. All right, so we don't want to have that happen. Each virtual machine adapter in a virtual machine has its own initial MAC address, and it's assigned when the adapter is created. Now, of course, it's assigned a specific MAC address based upon what VMware has purchased. Remember, all of these different vendors have their own specific set of MAC addresses associated with that. The virtual machine's operating system can't alter the effective MAC address to any other value, and then we can spoof that, and we can, of course, gain access to information we should not have access to. In our wonderful little security tab, VMware has said this is all the security they need. Well, not really, but I'm picking on them a little bit. So we've got this promiscuous mode. We're setting that to reject. Now we've got the MAC address changes and the forged transmits. Well, the MAC address changes, this option by default is set to accept, which means that you can go in and change your MAC address on your operating system, which would allow you to spoof things. Now, we can also do forged transmissions. That by default is set to accept, which means that it will not compare the source and effective MAC addresses. It will allow those packets to be forged and changed when they're transmitting traffic from one to the other. Now, some of the attacks, especially the man-in-the-middle attack where we're doing some ARP cache poisoning and things like that matter, it doesn't matter if this is accept or reject. That's still going to function, it's still going to work fine, but it will prevent or could prevent some other types of attacks where we're trying to spoof or gain access to specific devices. Because remember, just because we're doing a man-in-the-middle does not mean that we're changing our MAC address or we're even forging it. We're just telling one machine that we're somebody else. We're not doing anything out of the ordinary there, so that stuff is not going to fix this here. But we do still recommend that it's a good idea to set this to reject. It will at least keep some other users from causing some other malicious activities outside of some of the attacks that we talk about. When it comes to securing the ESXi host console, we need to make sure that we're taking the time to protect the attacks that will come in over the network, that anyone that has access to the console might be able to cause problems with regards to that. So for an ESX, which runs a service console, one way to guard against that is to use what's called GRUB passwords. That will prevent users from being able to boot into the single user mode and therefore passing options to the kernel during the boot process. We don't want to have that happen. We shouldn't be able to pass options into the kernel when the system is actually booting. So unless the password is entered, the server boots only the kernel with the default options. It will not allow anything else to happen or occur. This is something that is recommended. If you need some more information, you can go read the GNU GRUB manual. It's not difficult to do. It is a good way of protecting against bad happenings when booting up the ESX or the ESXi host console.